Hi everyone. Yeah, I'm just going to run you through the chi-squared statistic because I think most of you will probably want to use this for your IA. So I've just taken an example out of the textbook, and this one here's got on this column. So you could conduct a test very similar to this. It says own cell phone, do not own cell phone. And then, so on this, you either own a cell phone or you do not own a cell phone. And then what they've done is they've collected this data of people between 18 to 34, 34 to 54, and 55 plus. And so there's something very similar that you could actually collect yourself. Now, how do we do this chi-squared? And you can see the question down here. So we would need to do very similar to this if you had this similar sort of two-way table in a IA. So it says use the chi-squared test at a 5% significance level to test whether the phone cell owner is independent of age. Okay, and we'll talk about what this means, is independent of age. So again, to test whether the phone cell ownership is independent of age. Show all stages of your test, including the null and alternative hypothesis, the number of degrees of freedom, and the expected frequencies. Okay, so I'm going to run through all of that. The first thing that I want to talk about is the null hypothesis. So the null hypothesis, and this is just, I've just cut this out of your textbook. All chi-squared tests start from the assumption that the two factors being tested are independent. This independence is stated as the null hypothesis. So I think I can just, what would be our null hypothesis in this case? Well, it would be that ownership of a phone is independent of age. So I might just write that down. Ownership of a cell phone or phone is independent of age. So that's my null hypothesis, and that's called H0. So if you like, we'll put here H, and I should put a little 0 down here. I can superscript 0, I think, up here. No, sorry, subscript it. Control Z. So we'll go H, and I'll just put a little 0 here if I can. So 0, H0, and that's H0. So there's my null hypothesis. Ownership of a phone is independent of age. Now, in contrast, again, I'll just cut this out of your book. In contrast, the alternative hypothesis would be H1. I'll just write this down here. H1. I should subscript this, which I will do. H1 here, just because it is a little one there. So in contrast, the alternative hypothesis H1 is ownership of a phone is dependent. It's dependent of age, or on age. It should be really there, shouldn't it? I should say on age. Dependent on age. I'll put on age here. So that's the first thing that you do. You basically create these two statements here. There's that statement. I'll make that nice and big and bold. I'll change that to 14 and I'll bold that. So that's the first thing that you do in this chi-squared test. You create these hypotheses. One's called the null hypothesis and the other is called the alternative hypothesis, and I can help you with those if you need that. Okay, so let's show all the stages of your test, including the null and alternative hypothesis, the number of degrees of freedom. So let's just jump down there. How do we work out what the number of degrees of freedom are? Well, the number of degrees of freedom depend on how many rows and columns that you've got. So for the number, I'll just use this symbol, number of degrees of freedom is simply equal to the number of rows you have minus 1 times by, so that's basically n minus 1, the number of rows you have, and then you multiply that by the number of columns you have. So maybe I should call that NR. So NR, we'll say NR, number of rows, minus 1 times number of columns. minus 1. And you're probably wondering, why is this? Well, we don't really need to worry about why. It's actually quite complex why we have this thing called the number of degrees of freedom. Let's just use it. Let's just understand how to use it and not worry about where the mathematics actually comes from. So the number of rows, how many rows do I have? I have 1 row, 2 rows, 3 rows. So it's basically 3 rows minus 1, which is 2, times by. How many columns do I have? 2 columns, 2 minus 1, and equals 2, in this case 2. So it's 2 times 1, which is just 2. Now that's really important, because if your number of degrees of freedom is actually 1, you're in the textbook it says we really can't use the chi-squared testing without doing another test. So it's good, everyone, if you can please, if you're going to do this, break your categories up so you create 3 categories here. Okay, all 3 categories here. Now, I don't know how you could do it. You either own a cell or you don't own a cell. So age is clearly the thing here where you're going to need to divide that up. Right, now we move along. The chi-squared statistic is a goodness of it. In general, the chi-squared statistic can be calculated using this formula here. And at this stage, look, I'm not really going to worry about how you might do that. I might do that in the next video that I make. I just want to get to how you should calculate it to find this chi-squared statistic. But I will, though, talk about the expected values, because you'll see here the number of degrees of freedom and the expected frequencies. Okay, so I do actually want to talk about how we would get our expected frequencies from this particular table. So what I've done here is I've made a spreadsheet, and the first thing is I've taken out this data like so, and you can see that. Next thing I've done is I've added up columns. So I just want to find out how many people are we talking about. In other words, how many people own a phone? Now, we've got 440 plus 590 plus 770. So in this column here, I'm going to put what would be a total for how many own a phone. Down here, I'm also going to put the total for how many do not own a phone. So I'd put a total in there. And then we could actually get a grand total of how many people are actually involved in this. Now, there's another way we could have done that. We could have added up this number and that number to get the total of 18 to 34s. We could have added up this column and that column to get the number of total 35 to 54s and above 55s as well. And that should add up to the same total. Now, I've actually done that. So that's on sheet 2. So if we go to sheet 2, I've actually done that for you. So this is the total that own a phone. Yeah, this is the total that do not own a phone, and this is the grand total. So we're talking about 2,213 people. Now, that should add up this way as well. In other words, the people aged between 18 and 34 total is that amount, 468. The people 35 to 54 is 676, and the people above 55 is 1,069. Now, those 3 add up to that total. Those 2 add up to that table. So it's a good idea to actually show those totals there in your book. Oh, sorry, well, in your calculation. Now, I'm doing this in Excel only because it's easy just to add up everything, but you could show as a simple calculation how to do that. Okay, now I want to talk about the expected frequencies. So what I'm going to do is remove everything in here. What would we normally expect this number to be if for instance, you were given those totals without any numbers in between? And I'll just get rid of this because I've already worked it out before. So what I might do is I might see if I can actually drag this here into, I'll just Control-C that. I'll see if that will drag into a whiteboard for us. Let me just see. There's my whiteboard here. Whiteboard, here it is. And I'm just sorry, that's just taking a bit of time. I'll just get a new whiteboard up. New whiteboard. I'm just going to see if I can drag that Control-V. Here it is here. So what I'll do is I'll just reduce that. I'll make it about that big and put that there. I'll make it a bit bigger. Okay, so I've got my data here. Now I've added up, and I'll just go with a pen. Just grab this pen here. Grab that. Okay. So what I've done is I need to work out what would you expect in this case based on if I was to give you that you had this number of people who own a phone out of that total number, yeah, and I told you 468 people were aged between 18 and 34, how would you work out what that expected probability, if you like, is? Well, the way I'm going to do it is I'm going to say, what's the probability of owning your own phone? And then I'm going to multiply it by how many people are between 18 and 34. Okay, so what I would do is I'd find out what's the probability to own your own phone. Well, the probability to own your own phone, so let's just write this down. So the probability to own a phone, the probability to own a phone is simply going to equal to that number there divided by how many people's in our test. So that's the probability to own your phone, own your own phone. Now, the expected people, so if you like, what's the number of people that will be expected? And I'll write this word down because that's the word that the chi-squared use, expected. What's the number of people expected to own a phone between 18 and 34? Well, that's simply this probability here, yeah, because that's own your own phone times by how many people are in there. And that's kind of like what we did in that last chapter. So we've got 1737 on 2213 times by this number here, which is 468. Okay, and I'll just grab a calculator because I'll just work that out. I think we've got one here. Press menu. What's going on? I want to add a. Okay, so I've got 1737 times by 468 divided by 2213, and I end up with 300. So the answer I get for this, and we'll just keep this answer, is 367.337. Okay, now more generally, I think you can probably see here, there's a formula here. There is a formula. In order to get that expected number there, and I'll just grab green here. In order to get that expected number there, what I needed to do was take this number here, multiply it by that number and divide it by that number. Yeah, so the expected value in any column, is just the number in that column, yeah, times by the number in the row and divided by the total. Yeah, so let's just say if I wanted to find what would the expected number of people in that one be. Okay, again, wanted to say the expected number of people in whatever that column is called is simply, we'll just put expected number of people in that column is simply equal to the number in the column, which is 1069, times by the number in the row, which is 476, and divide that by the total, 2213. Now, let me just do that and enter that in. So I've got 1069 times by 476, and I divide that by 2213, and I end up with, this ends up with 229.934. Now you can show some of these calculations in your IA. What I want to do is I want to show you how your calculator can very, very quickly get those numbers, okay? So I probably will bring that over because I just want to copy in that example in. So I'll just copy that example straight into my calculator and you can see that. So let's go here to my calculator. I've already put this in. But I'll do it again. So I'll just go to menu. I'll make a new thing here. Yep, I want it all new. Oh, hang on. Cancel. I want new. Do you want to save documents? No, I don't. I just want to add a new calculator. So let's just start from scratch. Right. How do we enter in this particular matrix? Now, what do I mean by the matrix is how do I enter in those numbers there? How do I put these numbers, which are the ones that you're given, how do I put those into the calculator? So let's just quickly do that now. So go menu, and we want to establish a matrix. Okay, so go here to matrix. I want to create a matrix. So I'll just get down to there so you can just see. So go menu, 7, 1. And what comes up here? And how many rows have we got? Well, we got 3 rows, and we got 3 columns, and 2 rows. 3 columns and 2 rows. Okay, and that will come up. Then just enter in the values 440, and we want to go to 590, and then we want to go to 707, and then we want to come here to 28, and then I want to go 86, and then I want to go 362. Oh, 362. Yep, there you go. So I've entered in all those values. Now what you've got to do is you've got to store that. You've got to tell the calculator that that's a particular matrix. So we've got to store that. Now I've just got to remember how to store. I think it's Control and here, just the one above VARS, VAR. So I'm going to go here and store that. So see Control and that button there, and that there gives me, and I'll put that as matrix A. Now that's stored as matrix A into my calculator now. So I've stored that as matrix A. What I'm now going to do is very, very quickly, I can find the expected matrix. This is how easy it is. Go here, and no, not Control, just go, I'll just go straight to VARS. Hang on, let me just go back here. I just need to go, hang on. Let me just get rid of that. So escape. So I want to go VARS. So I've just unlocked everything, so there's no escape or no control, and I just press VARS. That's not doing it now. Try that now, VARS. Right, that's not working. I wonder if it's because I've got to do this. So what I might do is go to menu and go to statistics, which is 6, and then go to stat tests. And then the one I want is the two-way chi-square test, which is this one here. Okay, so I'm going to press that, and I'm going to put in matrix A and press OK. And I end up with all my chi-squared information. Okay, so that's how you get that chi-squared information up. The thing is, though, I want this expected matrix, and I think I had to do this first before I went straight to VARS. So if I go to VARS now, aha, it all comes up. So that's what I needed to do. Did everyone see how I did that? I'll just do that again. So go menu, go to statistics, yeah, and then we want stat tests 7. So, and then we go straight to the chi-squared or chi-squared two-way test. And we put in the matrix we want, which is matrix A, because that's what we're working with, and press OK. And that comes with all of this stuff. Now, I'll interpret all this stuff for you. So here's the chi-squared value, our calculated chi-squared value. And there's the p-value. Okay, now normally we refer to the chi-squared value or the chi-squared value rather than this p-value, but I'll talk about the p-value in a moment. So let's get the expected matrix up again, just VARS straight away. So now once I've actually done the calculation, which is what I should have done, just press VARS, and look, we can just go here to my stat expected. So EXP means expected, stat expected matrix. We press that, and we just put matrix A, we tell it we want that one, and press enter. Aha. No values are assigned to the variable. Why is that? So I'll just try that again. I'm not sure what that is. Do I need to put that in? I'm not sure what's happened there. Done. Oh, okay. I don't think I have to tell it. I don't think I have to tell it that it's A. I've just got to go and press enter. Sorry, excuse me. Yeah, so I didn't have to. Once you've done the calculation, you'll have to excuse me. I haven't done this for a while. So yeah. So once we get this information, all what we do is we go straight to VARS, and we can just press. We don't have to tell it that it's number A. So my apologies for that. So we can just get the chi-squared statistic or the expected matrix. Now this is the expected matrix, and if we go back to that sheet, you'll notice this number here is 367.337, and this one here is 229.9. You'll notice that's exactly the same as what I've got here. Yeah. So do we actually need well, it would be good in your IA to show one or two of these calculations, yeah, how you actually get that. But essentially, you can also use your calculator to check what the expected values are, or what the expected matrix is. Now, how to get the chi-squared value? Well, I might do that in the next video, but just in this video now, I'll go back. So I just want to test now. I'll go back to my Word document. I just want to test now to see whether we reject this null hypothesis. Now, the null hypothesis ownership of a phone is independent on age. Okay, but just before I do that, I'm going to grab that chi-squared value here, which is 194, and I'm going to write it on this document down here. So I'm going to go to this document, and I'll just put a space here, down here, and I want to write that my chi-squared value was equal to 194. And what I'll do is I'll actually grab a pen here, so because it'll be easy to do that. So just in here, I'm just going to write that my chi-squared value, now this is my calculated, yeah, was about 194 to 3 digits. Okay, so I'm just going to write that there because that's going to be important. Now, before I actually tell you how to calculate, we can actually calculate this value from first principles rather than using a calculator. Now, I used a calculator, yeah, but in the next video, I'll show you how to actually work that out from first principles, which I think is good to show as well. Coming down just below where I've got that is I've got this here. It says, and I'll just enlarge that a bit because you might find it a little bit hard to read. I'll just enlarge that just a bit more. You'll see here, if the chi-squared calculated value is greater than the chi-squared critical, then you can say the result is significant and the theoretical distribution is not a good fit for DAS. So therefore, what I'm saying is we can actually reject. Yeah. So if our chi-squared value calculated is less than the critical value, then I can actually reject my null hypothesis. If it's greater than my critical value, then I must accept my hypothesis. Okay. Now I think I've got, just hang on for a moment. Yeah. And it also depends on our number of degrees of freedom. So we've also got our degrees of freedom from our calculation before. So we'll just write degrees of freedom here. Degrees of freedom. That should be freedom. And my degrees of freedom, which we'll just write DOF, degrees of freedom was equal to 2. So both of that information now can help us to get this chi-squared critical value. Now, this is really, to get the chi-squared critical value, you simply go to a table. But the table depends on what we call the significance level. Now, this information is given to you in an examination. But generally speaking, in statistical analysis, we tend to use a significance level of 0.05. Now, you can also call that a 5% significance level. So this is a 10% significance level, this is a 2.5%, and so on. So this is the one we tend to use, and this is the actual chi-squared critical values that you'll be given in the examinations. Now, the degrees of freedom is on this axis. So we've got 2 degrees of freedom here, and I'm going to use a 5% significance level. So basically what a 5% significance level means is I'm 95% confident that there is either independence or dependence depending on whether the test fails or succeeds. So if I look here, my chi-squared critical value is 5.991. So I'm just going to go back up here and I'm just going to look at this situation here. So I've got my calculated value, I've got my number of degrees of freedom, and I've also now got that my chi-squared value, and I might just come down here, can I? So let me just look at all the information I've got. So I've got my chi-squared calculated, which I calculated was approximately 194. I've got my chi-squared critical, which is about 5.99, And in this case, I've got my degrees of freedom, which I used to get that. Degrees of freedom, which was equal to 2. Now, this I got from my calculator. Yeah, this is ridiculously easy to work out. That's the number of rows you have minus 1 times by the number of columns you have minus 1. This here will be either given to you in the exam, or you can look up from a table, just like what I did. However, in the exam, they won't put the table. They may put the table, but generally speaking, they actually give you that value. Now, the next thing is, do I accept or do I reject my hypothesis? So if my calculated value is less than my value, I do not have enough evidence to reject H0. In other words, the data does not support the claim that the pass rate is dependent on the examiner. So what I need to do is I need to confirm and I need to accept the null hypothesis. I think that's what it is. Just hang on for a sec. Yeah, so if your calculated value is less than your chi-squared value, you do not have enough evidence to reject H0. So, in other words, my calculated value is much, 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 much bigger than my critical value. So I do have enough evidence to reject the null hypothesis and accept the alternative hypothesis. In other words, this is what happens. If your chi-squared calculated value is greater than your chi-squared critical value, yeah, then what you can do is you can reject H0. Okay, now rejecting H0 means you accept H1. Now, the opposite to that, of course, is if your chi-squared calculated value, I'll just zoom up a bit, if your chi-squared calculated value is greater than your chi-squared critical value, then the opposite is true. Yeah, we can, sorry, it's less than, so I'll just grab a rubber. Oh, rubber there, just rub that off. Yeah, if your chi-squared calculated value is less than, then we accept H0, yeah, and we reject H1. So let's go back to my conclusion here, not HI, H1. So let's go back to what my conclusion would be here, which would be, let's just go back. So in this case, if we have a look here, 100, I'll just grab my pen, 194, which is my calculated value, is much, much greater than my critical value, which is 5.99. So I can reject H0 and I can accept H1. So let's just go up here. So what does that mean in this context? Well, in this context, it means, ladies and gentlemen, that I can reject this one here. So ownership of phones is independent on age. Well, I have to reject that. However, I can accept this one here. So the ownership of a phone is dependent on age. Okay? And that's basically how we go. And you could almost sort of say that. You can see that most people up here, the older you get, the greater the likelihood you are of having a phone. So it kind of makes reasonable sense in terms of looking at our data just logically. But that's the steps that you need to show that you're basically 95% certain, yeah, that the ownership of a phone is dependent on age. Now, of course, if the chi-squared value was much, much less, if this value was less than 5, then, or less than 5.99, then you would accept this, and you would say, hey, hang on, no, ownership of a phone is just completely independent. There's not enough statistical weight to reject that null hypothesis. Okay, so you always start with a null hypothesis that this is independent. So you always start with that. Okay, and we're trying to, if you like, to disprove that statement via this method. So that's about all that we have to do. But can I just come down here in this video, and in the next video I'll show you how to calculate actually the chi-squared value. So if we come down here, there's a couple of things that we need to consider, and this is very, very important. So what I might just do is, have I got my pens here? Yeah, I have, and I might change that color here. Good, I've got another color. Good. Okay, these are the things that we have to actually think about. So I would say these are things that we have to validate. Do you remember that criteria that we talked about the other day in your maths studies criteria sheet? These are things that make what you're doing valid. Yeah, okay. So the first thing is the categories for each variable must be mutually exclusive. In other words, they cannot occur at the same time. Now that's the case. You either have a phone or you do not have a phone. So they cannot occur at the same time. So you can't be 18 years old and in the plus 55 category as well. So age is a very good discriminator. You can't be in two places at once. You can't be two ages. Okay, so having something or not having something. So you do have to design your experiment or your test so that things are mutually exclusive. That's generally something we don't have to worry about because they just are. Okay. In a 2x2 contingency table, no cell should contain an expected frequency of less than 5. So if your 2x2 table, now I wouldn't recommend a 2x2. Okay, I would recommend a much bigger one, like 2x4 or something like that. So in other words, those age groups could be divided into 4 categories. So yes, you can have male and female, for instance. You can have own a phone or not own a phone. Yeah, you can have off or on, so to speak. Yeah, so this one here, it's okay to have 2, but in this one here where we're going to divide by age, I would be looking at least 4. So you've got a much bigger contingency table, so you don't have to worry about this particular criteria here. In larger contingency tables, okay, so let's say we have got a larger table, one with more than 2 rows or 2 columns, which I would expect most of us would have. No cell should contain an expected frequency of 1 or less. Right, so that's got to be one criteria. And no more than 20% of the expected frequencies should be less than 5. Okay, so that's something to consider. Now, if I went back to my other table here and looked at my expected frequencies, hang on, where was my expected frequencies? That was on the calculator. Sorry, if I go back, look, none of these, are anywhere near 5. So I'm more than satisfying the conditions for the chi-squared test. So I could say in my conclusion or in my valid statement that, yeah, look, everything's fine, So it's well worth copying out some of these and just showing that you satisfy them. The last one, if there are expected frequencies in the table that do not satisfy this. So let's say you've got this condition here and you're really worried about it. Don't panic, because we can actually combine some of the cells. Yeah, so I might be able to make, for instance, the age groups much, much less. Okay, that's the first video in how we actually apply the chi-squared test. It's probably worth having a practice and doing some more yourself. Okay. The next video, which will be part 2 in this, is I really want to concentrate on how you would actually now conduct this here. How do we actually get from first principles to chi-squared? Now, I just went straight to the calculator and got it. Okay. But how would you calculate that yourself? That will be in part 2 of this video.